Alright, good afternoon. My name is Joseph Okompaku and I am a mathematics teacher. I teach pure mathematics and A-level statistics and mechanics. Today I want to introduce something briefly to you. This is a lesson or a topic in Pure Math Level 3 Cambridge International Exams. And it is an aspect of mathematics we call calculus. Now, calculus is a very important part of the whole field of mathematics. In fact, engineering is possible only in the premises of calculus. Calculus does a lot of help to the field of engineering. For instance, with regards to integration, architectural engineers are able to quantify the materials required for constructing curved constructions like a dome, okay, or any kind of building that has a curved decoration in them. Then when we come to electrical engineering, they are able to apply calculus to quantify the length of cables or wires between substations. Even for spacecraft engineering, they need integration to be able to do a lot of things in exploratory probe. And that is why this is so important. As a student, you may need to know this because if you want to be an aeronautic engineer or in any of this engineering field, you cannot do without calculus. And today I want to introduce something to you, which is integration. And I'm introducing this by solving a Cambridge past paper. And this is important because you are not only learning to expand your skills of mathematics, but also to write exams and pass. And so for the purpose of this presentation, I want to just solve this question, and then we will say goodbye until I meet you again. Alright, so here is the question. Okay, using the expansion of cos 2x plus x, show that cos 3x is equal to 4 cos cube x minus 3 cos x. Hence, or otherwise, prove that the integral of this should give you 2 over 3. So let's begin that. Now, you need a firm foundation of trigonometry, especially compound angles, double angles, and then you need another skill, which is integration, to be able to prove this, okay? Now, let's start with the big part. We know that cos 2x plus x is a compound angle. Now with compound angles, using the formula, we can obtain this identity, which is cos 2x cos x minus sine 2x sine x. So because of this, this is a double angle, so we have to do further expansion. So we're going to have cos squared x minus 1, and then all of this multiplied by cos x. Now this is going to be 2 sine x cos x with another sine x. You can find this in the formula tables, but usually I advise students to memorize these simple formulas. So when we expand this, we are going to have 2 cos cube x minus cos x. And then when we expand this also, we're going to have 2 sine squared x cos x. I believe you're following me. Then we realize that this can also be simplified in a way that it will include cos x, because when we look at our final result, everything is in terms of cos. So we have to do another substitution for the sine squared x, and of course we come back to one of the basic identities in trigonometry. So we have 2 cos cubed x minus cos x minus 2. Now this will be 1 minus cos squared x. Now all of this will have cos x multiplying. So we will get we're going to get something like cos x minus cos cube x. And you do further expansion, and you get minus 2 cos x plus 2 cos cube x. So the final simplification, you're going to have 4 cos cube x minus 3 cos x, and this has been proved as in our original problem. Now let's get to the second aspect of this. Now we say hence or otherwise prove this. So it means that the result of this expansion could be helpful to arrive at our desired solution. So in this expansion, we realize that cos 3x is equal to 4 cos cube x minus 3 cos x. So because we are looking for this, we can make cos cube x the subject and then try to go somewhere with that. So by so doing, we're going to have cos cube x to be cos 3x plus 3 cos x all over 4. Now when you obtain this, you can put it back to this integral and then do something with it. So we